All right, so here we are. We're going to be looking at the answers to our homework. So check out 8.4. Look to see if you guys have any questions about these. Obviously you can come in for extra help as you would choose, but I just want you guys to say, do you have any questions about switching forms? E is a valid number, but just like pi, you can represent it as the letter E. All the properties that you've ever learned are true about logarithms. So if you want a minus 2 logs, yes, you can divide their arguments. But before you put these two logs together, you have to put that 3 up as a power. Okay, you have to stow the coefficient in front. Okay, so before you subtract 2 logs or divide them, you've got to stow the coefficient out front or out front up to the exponent. Do you guys have any questions about these? Some of these are ugly, I'm not gonna lie. You're like, oh, really? We didn't notice.
For 1 through 4, do you have to put the E?
No. On 1 through 4, you don't need the E. I like to put it because I get a little scared, but you don't have to put it at all. When you write natural log, it should have, if you write the word log, it has to have an E, but don't write log, put ln, okay? So, anybody else questions? Okay, let's scroll down. Solving. How do you solve? Well, if it's an exponential, you isolate the thing with the power. So e to the x is the power. So you might add 1, divide by 2, and then switch forms to solve for x. Okay, so that's how you switch from an exponential to solving for x. Because if the variable is too high up to reach, you need a logarithm to help you reach it. Any questions on 15 through 18? Any questions on that? Tomorrow we're going to take a quiz over section 3. Okay, we'll do some in-class practice of some word problems. And then we'll take a quiz on Friday over 8.4. That's currently what we've got going on. And then to solve a natural log equation, obviously, if you've got 2 lins or 2 logs on one side, you've got to put them together as a single log. And then the next thing is, if you've got a log on one side, you switch forms to solve it. And remember, the base of a natural log is E. Any questions about what you see? Now, if your brain is saying, I am lost, you lost me like 3 days ago, you need to get your cute self in, because this is a best in layers. So if you're like, wait, you need to go back a couple days, let's talk. Let's get you caught up to where you need to be, because it is little layers of learning. Okay. And so, any questions? Now, word problems. Okay. Some are grosser than others. So like, don't lose your mind. I'll talk to you about what you need to know. I actually do like number 23. That's a fabulous one to do. Okay. So on the first one, it just gives you the information on the right side and you evaluate the right-hand side. The second one says begin with 4,000 and end with 6,000. I like that one too. Your first step is to divide by 4,000 and either write as a fraction or divide it. And then you move over here. And then to solve, when the variable that you're trying to solve for, that t in the exponent is going to be up there, how do you do it? Is switch forms. So switching forms, evaluate this logarithm right here. And then when you're done, divide by 0.0346, I believe. Does anybody have questions about the 23A or B? Those are valid questions to do. The next one says, how much do you have to invest in order to end up with this? So you're solving for the coefficient in front of this value here. So to isolate that P, that beginning value, you're going to divide both sides by this whole snarly thing. Your calc can handle this big fraction of 10,000 over this E to that power. And then this will give you the answer. Okay. How many of you guys got that one right? Okay, good. The next one, I plan to give you like a formula to be like, hey, here's the formula. Can you follow what you're doing? Okay. On your test, absolutely for sure, there is a question like number 25. Okay. 25, where you have to say, can I use my brain to break up the two given I've got plus the ones that go with the function. So you took this on your last quiz where I was like, hey, if it was log base 3, then log base 3 of 3 would be an option. Log base 3 of 9 would be an option. We're not going to do E on these guys here. So what you can do is, can you break it up in terms of just these two specific things? Okay, so what we need to talk about today is half-life. Okay, so probably what I should do is say you should at least do 28, okay, for homework. Okay, and so I need to teach you about half-life, and then I should have you try 28 for homework. And then we'll do lesson 8.5. So let's get out our homework, our notes. Does anybody have questions about this so far? Okay, so let's look at our notes. Okay, so we talked about natural logarithms yesterday, okay? And we just basically said, let's kind of rehearse, our logarithm skills. And then I said, let's practice switching forms. Let's practice using the properties. Let's practice solving exponential and then solving logarithmic. Okay, and we got through about here on the notes. Okay, so we got through about here. And I'm trying to see if there's anything amazing that I should have you guys practice. We did number 13 in class together. Is that right, you guys? Okay, we did 13. Okay. And I'm trying to think of, like, is there anything? Why don't I have you guys do number 11? Okay. And I'll have you do number 9. So why don't you guys try number 9 and number 11? Okay. And we'll go over those to see, can you get the right answer on those ones? Okay. If you're bored with those and you get them done, you can look ahead to number 12. Okay. I'm pretty sure number 12A was on your homework. That's a big number. Did you guys get that for your answer on the first one? Okay, good. Any questions? Let me know. I think I look and see, does either of your answers make either argument 0 or negative? The -2 will make this argument to be -8. That's a problem. Okay, so we throw away that second answer. Any questions on that? Hey, on this one, can you write this in terms of the two logs that are given? Okay, can you write this? Josh, do you have any idea how you'd write this as two logs that are given? Yes, 12a. Yeah. You guys see that? Because if you want to add two logs together, you multiply their arguments. So the ln of 35 equals that, okay? And so what you would do is 1.609 and add on 1.946. And the sum of those, you're like, I would like to use a calculator. I know, it's going to be 3.555. The next one really is 5 times 5 times 7. So you could just do the ln of 5 plus the ln of 5 plus the ln of 7 to get you that answer. I need to make sure the numbers aren't too super big, so that you can do these without too much pain. Okay. What I want to do now would be talk about some of the word problems, especially the half-life, because I think that's going to be, it's a little new. The concept of half-life is something you might have seen in chemistry, but it's something that's new to us right this second. Okay. So I want to remind us of our formulas. Okay. So we've got A PERT is going to be the one that has E. And so, you know, if you look at these guys and you did this probably on your homework, where you're like, if I begin with $500, 5,000 would be a wish. Okay. $500 and you are compounding continuously, then it would be E to the R. What number do I put for R here? If it's 3.5%, what number should go up here? Oh, wait a minute. Do you see that this is not continuously, is it? This is annually. So what should we put? 1.035 to the T. Okay, and so they're like, hey, use it. So I want to remind you, if it says annually, you still use that formula. And if they say do 7 years, you'd put a 7 here and you could evaluate that to get your answer. So a reminder of, hey, annually is that formula. Remember, if they say monthly or something like that, you would do 500 and then it'd be 1 plus 0.035 over n to the nt. Remember, n is how many times per year that they pay you. Okay, so if they're like monthly, both ends would be 12, and then T would be how many years you keep it in the bank. Okay, so, and then continuously, this is the one I originally did, was 500 E to the 0.035, and then times 7. So just a reminder of how to use those formulas. All right, how are we doing time? 33. Okay. Okay, I want you guys to try both C and 13, please. Okay, see if you can find those two answers. You can use your calculator, and then we'll talk about half-life. I just put up the first answer. You just plug it in like normal. You begin with an amount, you end with a certain amount, and it's e to the 0.05 times 20. The question is, how do you isolate p? Well, it's related by multiplication. So we're going to divide both sides by e to the junky thing. Your calc is so good. She knows how to put that in there. Okay. So all you have to do is put that fraction and your calculator will evaluate the quotient of those two values gives us that much money. Questions on the first one? Alpha y equals enter will give you that fraction. this is how I'm setting up the second one. And here's the deal. And this is an important thing. There are times, I don't know if it's on your test or if it's just on your homework, where they're like, so how much would it take for your money to double if you have 4% interest compounded continuously? And there are times that they don't tell you how much you start with. My question is, does it actually matter? No. Start with an amount and then put on the other side twice as much. Your first step is to divide both sides by 100. Okay. If you divide both sides by 100, what do you get? Well, 2. Okay. So if they tell you, hey, I've got this interest rate compounded continuously, how long till your money triples? You're like, well, how much do you start with? It doesn't actually matter. Pick a number to start with, put triple the amount on the left side of the equation, and then your first step is to divide anyway. So it doesn't actually matter. Okay, so that is just a good thing. So if you got 2 equals e to the 0.04t, switching forms, we've isolated the power. The only thing that here is e to the power. So let's do ln e 0.04t equals 2. Put this in your calculator, and when you're done doing that, divide by 0.04, and your answer will be 17.33 years. Did you guys get that? Okay. And because it's compounding continuously throughout the year, you have to wait for 18 years, okay? It's throughout the year you're getting paid. So 17.33 years, okay? Now, questions before I move on. Half-life is a beast, okay? Have you learned about half-life in chemistry? I'm going to teach you about it now, okay? It's not intuitive, okay? So hear me out, okay? Half-life is true for radioactive material. It's also actually true for medicine that you take to some extent, okay? Now, with medicine you take, so say that you take Advil, okay? You can redose as long as it's kind of been metabolized in your body, right? You can redose it and be like, oh, I still have a headache, or my pain from my surgery is coming back. I need to take some more medicine, okay? Half-life means if you wait this long, half of the material will no longer be active, okay? So, say that you take like 500 milligrams of Advil, and say like after 3 hours, half of it will no longer be active, okay? Half will be, half won't be. If you wait that time period again, another half of what was still active will be deactivated. Okay, so it's like if you wait that time period, half of whatever you have in your body is no longer active. Okay, so you wait that time period again, half will be gone. Wait that time period again, half of whatever was left is going to be deactivated. And so with radioactive material, what you do is you start with this much radioactive material. Okay, so I'll tell you what to start with. And the thing is this, if you wait this many years, guess what? Half of it will be active and half will be inactive. Now, my logical brain says, you wait that long, we'll all be dead. But first, second of all, if you wait that period again, the rest of it should be gone, right? The answer is no. It's basically whatever is there, half goes away. Will it ever go away? No. Okay. So it's half, and then half of what was left, and then half is what was left. So it's a really bizarro formula that it basically reduces by half if you wait that time. Now, my deal is this: I am not going to live that long. Sorry to break it to you. Okay. But most of us aren't. And so the formula to figure out half-life is very similar to what you're doing with all the pieces. Okay. So let's do this. This is your beginning value. Okay. So say you're like, normally we put $500 there. You know, now we're like, how much did you start with? Okay. Welcome back. I'm making a video so you can, pause in as you need to. So you start with this. N sub O means the amount. Okay. N is the amount at the time 0. So at the beginning, you had this much. And then this on the left is at the end, how much you've got. Okay. So beginning, ending. So normally we put money there, begin with 500, end with 10,000 or something. So those are the same. Now notice this decay factor right here is always a half. Okay, so notice our radioactive material, or how much vitamins or how much Advil we take, is reducing by a half. So that's always a half. Okay, and it's going down because that's smaller than 1. And then the exponent is actually time. Okay, this really is time. But do you see it's a fraction? Okay, it's because ain't nobody has time to wait for 24,000 years. Okay, so T actually on the numerator is how much you actually waited. Okay, and the bottom is the half-life. So if you wait 3 years, your numerator will be 3 compared to the 24,000 years you should wait for half of it to be gone. So the T is how long you waited. The half-life is how long does it take for half of that element to be absorbed, whether it's vitamins that are like 6 hours or it's radioactive material that's like 24,000 years. So we've got to plug in these values. Yes, that exponent represents time, but we write it as a fraction of how long you waited compared to the half-life of that particular vitamin or element that you're talking about. So in this first question, I'm taking a video so you can watch it. You were starting with 1 gram. We're saying I want to get it to 0.1 grams. And it's half-life, so there's always a half here. And the T is time, okay? Yeah. So the time we are going to wait is actually, we're going to wait, or we're going to find the time compared to the half-life of this element. Okay, do you guys have any questions about what I have here so far? Beginning, ending, at 1/2 because it's half-life. The time you waited compared to the half-life of whatever you're talking about. If it's Advil, it's probably 6 hours. If it's radioactive material, it's like thousands of years. Okay. And so if you wait 30,000 years, you'd put time as 30,000. Okay. We want to just solve this for T to find our answer. Now I'm going to do something stupid. Any questions at this point? My first stupid thing is in case the coefficient was actually a number other than 1. I'm going to have you remember divide by 1. Does it change anything here? Well, no, I'm just setting you up in case it's a 50. Okay. So you would divide by that coefficient. Why? To get rid of it in case it's a different number than 1. Okay. So then we've got, obviously that stays the same. Okay. And then we've isolated the exponential factor. So we're going to switch forms to solve it. So we're going to do log of 1/2 to the T over 24,110 equals 0.1. And what you're going to do is you're going to plump this in your calculator. And then when you're done getting the answer, you're going to times both sides by 24,110. Okay, so I can pull up my calc and be like, okay, grab your calc out. And we're going to do math alpha math. And we're going to type in 0.5, but it can put decimals down there. Nobody cares, 0.1. And then we're going to times it by 24,000. And so we have to wait. The time you should wait is about 80,000 years. Okay, with Advil, you're not going to have to wait that long, okay? Because the half-life for Advil is more like 6 hours as compared to 24,000 years. Okay, and so I feel like we should do the next 2 questions, okay? They're the same, so if you can kind of get the gist, that helps as well. If you don't want to type in that next one to your calculator, that's completely fine. Just, I want you to get the gist of how you'd set it up. And then I do think that next, how long until 24% is left is actually a good question to talk about because it's weird. Okay, so my question is this. You know how you could do this one? Any thoughts? We need 24% of whatever we start with to be left. Does it actually matter what you start with? No. Okay. So you could start with 100 and then figure out 24% of 100. Okay. 0.24 times 100. And if you do 0.24 times 100, you get 24. Okay. You could start with 1 and times it by 0.24. Okay. So another option would be you could start with 1 and times it by 0.24. So it'd be 0.24 over here. I feel like that's a little awkward, but you can start with a number and whatever you do is you're like, I want 24% of it to be left. So that'd be 0.24. Actually, 0.24 times 100 is 24. And then you do 1/2, and then it would be T over 24,110. So how long till half is left? Okay, well then you put, you start with a number, put half of it on the other side. Whatever you say is what percent has to be left, figure out what percent of what you have is left and put it on the left side. Our first step is to divide anyway. And remember, never divide and get a decimal that you round off. You can leave it as a fraction. If it's a decimal that ends, then great, okay? And so then you would take this, okay? That actually makes 0.24. So you got 0.24 equals 1/2 to the T over 24,110. Switch forms. If you evaluate this and then times by 24,110, you're going to get T. And that is going to be 49,440 years. Now, don't be surprised if they talk about Advil, on your homework, or they're like, a vet doses a dog, 8 milligrams. How long till half of it is not, and the half-life is like 2 days, or half-life is like, they can change the half-life based on what they're doing. Okay, we're going to skip ahead and we are going to look at section 8.5. 8.5 is kind of harkening back to, can you write an exponential function? Okay. And so what we're going to do is they talk about some different formulas here. I am not going to lock in on those. I'm going to actually just use the one that we've done before where it's y equals a b to the t. Okay. So beginning, ending, growth factor, time. That's what we're going to talk about. Okay. And so we have to write this as ordered pairs. In 2016, there were 20.61 million people. Okay. So okay. So XY2. In the year 2000, there were 15.98 million people. Okay. Is our situation growing or decaying? Are there more people or less? It's growing, isn't it? Yeah. Because in 2000, there were 15 million. And then 2016, there were 20 million. Okay. So it's getting more. Okay. So can you write those and find the growth factor and write the equation this? See if you can do it. Do you remember how to do it? I'm gonna pause and see if you guys can figure out what to write. Okay. Oops. Okay, because the earlier time in 2000, there were 15.98 million people. At the end, there were 20.61. We need the growth factor, and that'll figure out, it'll find a growth or decay factor, okay? And then our time is going to be, it happened 16 years. Any questions about how I set that up? We just got to solve it for B. So let's divide both sides by 15.98. And then we've got B to the 16th equals that answer here, okay? And that answer, I don't know what the answer is, but then we're going to have to take the 16th root of it, okay? To get plain old stinking B, we're going to take the 16th root of that value. So on your calc, and I would say fire up that calculator, we're going to do math, and we're going to type down to option 5. We're going to take the 16th root, and the fraction we're going to put underneath that square root is going to be 20.61 divided by 15.98. Oh dear. Oh, there we go. Okay. You can do it as a fraction or a quotient. I can't do both at the same time. And then the answer to that will be 1.016. So when you write your equation, you would write y equals 15.98, and then that number 1.016 to the t. And then the next one says, when will you get to 25 million? Well, we can put 25 here. And we can solve that equation to find out how long until, if you begin with that and you end with 25. So I would say divide by 15.98. And then you've got that quotient, okay? And you're going to switch forms to solve it. So you do log of 1.016 to the t equals that quotient. I would put this fraction right there. And if you type that in your calculator, it'll give you your answer, and your answer will be about 28.19 years. Okay, so we're kind of practicing, can you write these equations? Can you practice solving for what you don't know? Let's see if we can set up the next one. We start with 20 cells. After 45 minutes, there are 710. $45 minutes, okay? Can you see how that kind of flows together and say beginning, ending, growth factor time, divide by 20, and then take the 45 root, okay? So if you divide by 20 and you take the 45 root, okay? Do you have a pass, honey? Oh, good luck with that, sweetheart. Okay. So if you take the 45th root of that, you're going to get y is equal to 21.0826 to the x. So this is just what we've been doing. We did this last chapter. We're going to do it this chapter. There is another formula. I'm just not going to teach it to you, you know? And I'm going to have us set up this last one real briefly. It says, if you begin with, it doesn't say how much you get. So it says how much is left if you start with 1, okay? And the half-life is 75,381 years. If you wait 1,500 years, will there be much left? Okay, so you can just plug that in calc and figure out how much will there be. So one big thing is start with stuff, plug it in, you're like, how much is left? You can plug it in calc and figure out what's. Now, your homework is to work on the section, do that one problem on section 4, okay? So do for sure in section 4. Make sure you've done number 25, do number 28, okay? Do number 28. And then do section 8.5, okay? Couple of them are a little weird. Do your best on those. On block day, what we'll plan to do is we will plan to do some more word problems and we will take a quiz over 8.3. Yes, Jonah? On section 4, we're going to do number 28, okay? And then we're going to do the 8.5, okay?